This is video 8A for our Systems Analysis and Design course, and it's entitled Systems Architecture. I'm Jim Renault, PhD from Shawnee State University, and I'll be taking you through this video presentation. Let's stop and think about the term architecture. An architect that builds buildings or that designs commercial spaces has to worry about placement, has to worry about the building, has to worry about heating and cooling, has to worry about zoning, has to worry about access for ADA compliance, has to worry about the environment, has to worry about all kinds of things. And you as a systems designer, you as a systems architect, you as an analyst, have to worry about all of those same things. It's a little different with us because we're dealing with software. We're dealing with arranging bits rather than arranging bricks and things. But we're still architects, no different. The problem, especially for a large system, is just as cumbersome as it is to build a large building. What are the components of the software that we're building? Well, the components of the software really are these four pieces that make up the software. So you can think of the software as a bucket, and then it's divided up into these four rooms, or building, and it's divided into these four rooms. We've got to decide how we're going to store the data. We've got to know how we're going to data storage. Now, in our analysis, we created something called the entity relationship diagram, where we figured out our entities, we figured out primary keys, we figured out attributes. Well, that's going to help us design our data storage. Will our data storage match our ERD from analysis? Probably not. But our ERD from analysis is going to feed us the information, feed us the ideas, let us know that we've not missed anything as we move into architecting our system. They're the data access level, which kind of sits on top of the storage. There's a language called SQL that you've seen or probably will see in your BUIS 2400 course or other courses, which is a common language used to grab data from a database. But our data access layer and what we're architecting for data access may be cloud-based, maybe a NoSQL based, maybe a custom file system. I don't know. So I kind of put SQL out there, but said SQL ... so that we can see that it could be that, but it could be other things that we're using for data access. Are we doing an object-oriented data access layer? I don't know. The next part of our software system, because remember the whole system is bigger than software. It's network, it's hardware, it's all of that security. We'll see slides for those in a minute. I think of it as the application logic. So the application logic comes from our data flow diagram. Each of the processes on our data flow diagram are application. The process for handling accounts receivable entry when we get money, the process for creating a sales order, the process for all of those things are data-driven processes, and that would be in the application layer. And then at the very end, there's something that I'm going to call the presentation layer, which is the actual user interface software. Whether the presentation is on a smartphone or on a website or on a thick client or a thin client application, I don't know, but the presentation logic is how we actually will use the software, the screens, the layouts, the forms, and all of that. And we're going to get it from the use cases. And some of the application logic we're going to get from the use cases. But the use cases will help us create that presentation logic. So think about the four components here of the software part of an architected system. So our software has to have somewhere to run. It has to have some hardware, doesn't it? So we have to also architect and design and create and plan and specify what hardware needs we're going to have. What servers are we going to need? What networks, what network backends, how big of networks, and all of those things are we going to need? What clients are we going to use? Are we going to put a smartphone in every employee's hand and run it on a smartphone client? Are we going to give every employee a desktop, a laptop? Are we going to do it web-based? Are we going to do it thin client, thick client? All kinds of things. So we have to architect our clients. Maybe we'll support multiple clients from a web server to a smartphone app to a um, so we have to really decide what our hardwares are. Now, there's a classic kind of architecture known as client server architecture, and it's something that we're all very familiar with. And I've already used the word thin and thick client, but let me define them terms. Let me define them now. In a client server architecture, we have servers that sit over here and manage the data or manage the application layer or average the data that manage the access to data layer. And then we have the clients where the user actually is doing things. And there are two different systems or multiple different systems. They can be multiple tiers. For instance, if we had a database server and then a database access server, and then we had a application layer processing server, and then we had a presentation server like a web server, and the web server sent data to this server, sent data to this server, sent data to the sent it finally to the data server. We would call that an N tier for n any number. Um, so it could be a two-tier system where you've got one server and one client, or one server and a group of clients, and the server has the data, the application, and all of that on it. Or it could be a N-tier, multiple tier, three-tier, four-tier, five-tier. Um, the other thing is clients kind of come in two general flavors, and there are all kinds of hybridness between the two clients, but let's call them thick clients and thin clients. For instance, a thick client would have the application loaded on the computer, and it would then transmit the data to the data servers or to the data access layer. So all of the application logic is sitting on the client's computer. That's what we call a thick client. It does a lot of processing, it does a lot of work, it does a lot of the stuff. Um, Now, one problem with a thick client is if we have to change how our software works, we've got to push that update out to all of our client machines. But an advantage is that all of the processing, or a lot of the processing, is offloaded onto the client. So each of our PCs are doing, or each of our clients or desktops or smartphones or whatever, are doing a lot of the processing. So, yeah, see, benefits, negatives. A thin client is a client that only handles the presentation, only deals with presentation. All of the application logic, all of the data access logic, all of the data storage, and all of that are off somewhere else on the network. So a thin client is a very simple little application, or a very simple little app or something that sits on the client and lets the servers out here deal with all of that. Um, it makes it small, but if there's no connection to the server, then there's no, you can't do anything. So a thick client and a thin client are two kind of interesting ways to think about. And again, that's all part of architecting your system, making the decision of what kind of clients you and your customer, you and your client want to use. Just with that brief introduction, I want to go a little bit more detailed into some server-based architectures. You know, think about the old mainframe computer where everybody just had a dumb terminal. You just had a screen with a keyboard, and that's it. And you typed in information, you got a screen of data, you got a screen, you looked at the screen, you typed something in, and all of the presentation layer, the data layer, the application layer, and everything were sitting on some giant server. We would call that a mainframe. The client, the terminal or the zero client or the ultra thin client, has no software, has nothing on it by doing that kind of big server thing. The great thing is that that zero client or that ultra thin client, or we used to call them terminals, has no disk on it. It has no USB ports. It has nothing. And it's really easy to replace. One of those dies, you just pull it out, swap a new one in, no software to load, no nothing. This zero ultra thin client is really kind of a neat thing. One of the local hospitals here in the area uses zero-based clients or zero clients, ultra thin clients. They're little boxes that they have a keyboard and a mouse and and a screen connected to. But all of the software is actually running through a Microsoft Terminal Services server on the back end remotely. So this thin client, this ultra thin client, has really no software on it at all. It's just a remote desktop software. And all of the desktop is being processed at a remote cloud, remote group of servers. So think about how that would work in a hospital situation. If that little terminal dies, maybe it gets water spilled on it, or somebody, maybe it gets stolen, or maybe it just stops working. Um, there's another one in the closet over there. Just grab it, plug it in, away you go. Just re-authenticate it, and it's done. Um, and there are no floppy disk ports. There are no USB ports. There is no way to drag and drop data off of it. There's no way to load a piece of software on it to do network to go sniff network packets or to try to hack into the hospital system. So by using something like that big server running Microsoft Terminal Services, um, and then using zero clients in each of the doctor's offices, in each of the examining rooms, really makes a lot of sense. Very secure for them. Think about mobile architectures. Do we have a really ultra thin client on our smartphone that only works if we're connected to the internet, that we're connected to the server on the other end? Or do we have a more richer client on our smartphone? Those are questions. For instance, if think of some games you play on your smartphone. Think of some applications you have on your smartphone. Do they work when you don't have cell service? Well, yeah, they do. Okay, so it's a rich client. They've got a lot of application logic here so that you can use it without being connected. And then when you get connected, it syncs up, cleans up the data, downloads the fresh stuff, uploads the stuff. So, I mean, a mobile architecture takes a lot more thought in many ways than the architecture of a desktop system. Are we going to do it cross platform? Are we going to make it work for the Apple and the Android and the Microsoft phones? I don't know. Is it going to work without a connection? Again, that's already something I've mentioned. Or is it going to be just a thin web client, a web browser on your smartphone, and if you don't have data at that minute, you don't work? Well, that doesn't make a whole lot of sense for some applications, but it makes sense for others. Virtualization also is kind of a way that we can handle this hardware networking thing. Virtual servers are basically little servers that run on top of big servers. So a virtualization would be where you have multiple little servers running on top of one giant server, where you partition a big server into little ones. Now the great thing about that is if we invest in one big giant server that's fault tolerant, that has fault tolerant disks, that has fault tolerant motherboards, that is maybe easier to maintain. And the great thing about server virtualization is that if you've got to bring one of your servers down, maybe you don't have to bring them all down. Communication between them is better. And you might be able to push resources over here. For instance, it's Christmas time. You need more power on your website than you do 1st of July because people are ordering Christmas stuff. Well, with a virtualized server, maybe you can slow down some processes. Maybe you can slow down some servers and take those resources that were used for other servers during the year when they need it and put it all into serving your website. I mean, that's kind of nice that with server virtualization, you can move stuff around and share resources a lot easier. Now, virtualization comes in kind of two flavors, private and public. A private virtualization would be you own the server and you then have it partitioned into multiple virtual servers, um, or using a public virtualization and using one of Amazon's server clouds, and then your server runs on top of Amazon's or Microsoft's or Google's or GoDaddy's or Rackspace's big server. And your server might be running, your virtual server might be running on the very same hardware as your competitor's virtual server, but the data doesn't cross. So that's kind of a neat way to get a lot of bang for your buck. I know the university several years ago bought a very large virtual server to run most of the university's applications. It's one big server, and then the servers to handle our email, and the servers to handle authentication, and the servers to handle our website are all virtual servers on top of that one big server. Um, and it's a way again to partition, a way to balance network use and to put the use where you need it, because we need more power behind registration on the midnight on the first day of registration than we do halfway through the term when nobody's registering. But we could use that power for other things. And you'll hear the word cloud thrown out a lot. But what is cloud but virtualization? We don't own it, we don't host it. Basically, it's a virtualized server that sits out on somebody else's network. We call it the cloud, but it's really just a server sitting out there that somebody else owns and they're leasing us a bit or part of it. The great thing about the cloud is it's secure if it's done right. It's scalable. If we need more space or we need more server or we need more, we just buy more or lease more. It requires the net because if it's out there, you can't get to it without some kind of network. And you could really think of the hardware as a service. The computers, the storage, the security, it's all just a service that's provided by somebody else. Again, if we don't need the internal expertise, if we can make a business decision that it makes sense to let somebody else handle that, the cloud is a great way to deal with it. But it's really just a catchphrase to catch server virtualization, to catch outsourcing, because that's really all the cloud is, isn't it? This concludes presentation 8A as part of our systems analysis and design course. This presentation was copyright 2020 by James Imbrano, PhD. All rights are reserved. And I'd like to say thank you for watching, and I hope to see you again in a future video.